All right, I think I'm recording, I hope. All right, everyone listen. I'm going to look at part F. So main thing on part F is going to be related to the following. You guys ready? Okay. So we know part C, hopefully you got the relative extrema. We have relative minimum at x equals 3. And I'm going over this because it's part of number or letter F. So I'm going to move on to and connect these two. To find the absolute extrema, we have to go ahead and use our bounded value and also our relative extrema we found on part C. So when I make my t-chart, my numbers are, I know I have 0 and 10 by the bound, and we also have our 3 as our critical point of the f of x, and that's going to give us some number, and I wrote it in a different order. 0 does give 7. If part C says x equals 3 is our minimum, shouldn't this be negative 47? And shouldn't that be 12007 basically? Yeah. So when you were going over it going, well, she said it's minimum on C, what happened on the other? I was just writing it mindlessly. So this would be maximum, and that will be our minimum, and that will confirm your answer on part C. Okay? So I'll make the changes on the website. On the second page, so before we go ahead and independently go over for another 15 minutes, on your second page, which one should I fully go over? And by the way, on 3 part C, if you kind of give me a general sketch, I'm okay with. Okay, don't worry about being very, very particular with the inflection. So should I go over 2 or 3? Oh, everyone says 2 online. What about you guys? 2? Are we okay with 2? Okay, I'll go over 2. And I want to clarify something on the graph. It looks like it's kind of there and kind of not. It's got a little tiny little x and tiny little y. So if you want to take your pencil and kind of make it bold, that might be helpful. It was almost not there. All right. Number 2, Aiden, let's read. Let F.
Let F be a function that is continuous on the interval 0, 4. The function F is twice differentiable. Set x equals 2. The function F and its derivatives has properties indicated in the table below. Given the information, the chart below, answer the following questions.
Okay, the first one say find all values at which F has a relative extrema. Let's all go ahead and underline. And did it specify minimum or maximum to us? No, because they did not specify, we have to go ahead and give 2 scenarios, one at minimum and one at maximum. So we know there is a maximum when our first derivative goes from positive to negative. Oh, yeah. And then vice versa, if the first derivative goes from negative to a positive, that's going to be a minimum. So let's go ahead and look and see where it's going to change. So our first derivative, here it is. I'm going from positive to negative. So I'm going to draw my arrow, positive to negative. What is this? It is a relative max. So let's write out. There is a relative max at x equals 1. Because now on this one, you can't say it changes sign. Be specific. What sign is it going from? Good. It changes from positive to negative. And then let's continue to look and see what we have. So it's going up, it's going down, it is going up, oops, and it continues to go up. Now, what happens in between, it doesn't really matter. So do I have a changing sign right here? So we have a relative what at x equals 2? Minimum. At x equals 2. And then our reasoning will be because f prime, now this time it's going from what to what? Negative to positive. Literally look at the chart. And then part B is asking us for points of inflections. So points of inflection happens when we have changing concavity. So I'm going to go back to my card. If my second derivative is positive, it's concave up. If my second derivative is negative, it's concave down. So let's physically draw that in our graph, not the graph, table. So negative, concave down, another down, up, and down. So how many points of inflections do I have here? 2, between these two and between these two. And it says find all points, and I'm going to write this in set notation. So then my first point of inflection is at x equals how many? 2, and my second one is at 3. Let's see if we can sketch this. Going up to my chart, we're going to sketch the function. So if you would go ahead and circle all the parts where the order pair is given to us, that will be a good start. So it says 0, -1. So 0, -1 is going to go right here. Oh, you guys can't see. There you go. And then 1, 0 is going to go right here. Then I have 2, -2. And then I have 3, 0. And notice it says to stop at 4, because if you see the condition, it says at the interval of 0 to 4 inclusive. So whatever I go up to at the 4, I'm going to stop right there. So let's see how we can actually draw this. We know we have a max at x equals 1, correct? And then we also know we have a min at x equals 2. And then we have concavity. So let's kind of look and see what's happening. From here to here, aren't they both caved down? So what I can do is continue to cave down until I get to x equals 2. And then it says from 2 to 3, I need to cave up. So when I cave up, it's going to look like this. Make sure it's got a little curve to it. And on the last one, we have to cave what? Cave down. So go up how much ever you want, as long as it looks like it's caving down, but stop at the 4. So just by looking at this within the interval, would you agree that is my absolute minimum? Would you agree that border is my absolute maximum? Okay, so the sketch is going to be very helpful in terms of finding that part out. All right, so now look at page, if you have to finish this page, that's fine. Now look at page 3 and 4, and let's do about 15-minute-ish. So I'm going to pause. What's up? Oh, no. If I did, it would be chewy and delicious. Those are the best. All right, I'm going to go over number 5. Number 5. So the graph given does not say which one it is. So by default, it's going to be understood to be our position. So let's write the following. F of 2, F prime of 2, F double prime of 2. All right. What picture do I see right here? It is a quadratic, and the quadratic, if it's given in as a position, it's going to be basically what kind of cave up. So we know we have concave up. So if it is concave up, I should write on here, if it is concaved up, we know F double prime is positive. So I'm going to put on here, it is positive because it is concave up. The next one, F of 2. So when I go to my 2, this point, is that positive or negative? This point is negative. Now let's go to F prime of 2. F prime is, what is my slope when it's changing from positive to negative or vice versa? That is 0. So just by looking at this, I can put it in the following order. F2 is the smallest, and then the 0 is next, which is F prime. And then positive number is bigger than negative or 0. Done. Are there anything else before I stop the recording?
Wait, can we go over page 2, the graph, like the very last one?
The graph I'm not going to worry about because it's going to be approximated. So you should be fine. All right, okay, we're looking at number 7. When you guys can see. There you go. You guys ready? If you're on your phone, get off of it. Trent, no. Put them away. All right, Trent, let's read number 7. Go. All right. Now keep in mind, the given information is the velocity. This right here is the velocity. Don't assume everything is given in terms of the function. Okay? So to find the average acceleration, and they gave us the range right here. All we need to do is find the average. So to find the average of that, we would say v of the n1 was 4 minus v of 0 all over 4 minus 0. And then go to your table. What is the velocity at 4? What's the velocity at 0? 2. And then we know 4 minus 0 is 4. And that's gonna give us basically 1 kilometers per second something. What happens to our denominator when we take it over the time again? Second squared. So we got that part done. Are we good on that? Okay. Part B. So let me move this up quite a bit. Okay. Oops. Part B is saying, is there a guaranteed time? Now, every time they use the phrase, is there a guaranteed time? Most likely the answer is yes. So we would have to use one of our theorems. Let's see if y'all remember the theorems. The first one is extreme value theorem. What's the second one? Mean value theorem, and then intermediate. Very good. So looking at this, I want to figure out, is there a time where the acceleration at time t is equal to 0? So we would have to find the slope of the velocity. So looking at this, if I want this to be 0, meaning 0 as our velocity, the two number has to be what to each other? Has to be the same. So do I have a location where they're exactly the same? Yes, I do. So we have to state the condition. When I say, is there a guaranteed time? Yes. V of t. And we want to put in our condition. Is continuous and what else? Differentiable on the interval given, which is 0 to 8. And then we can do our math. We have the numbers that we chose are from 2 to 6. So we're going to write out v of 6 minus v of what? What's the other x value that we circled? 2. All over 6 minus 2. Got our row too big. And the v of 6 says, what is our velocity there? 3. I know we chose the same one, right? And no matter what number on the bottom, I know it's going to give us 0. And let's write out our units. And then what theorem was that one? Good. By mean value theorem. A of t. Oh, look at me. A of t is equal to 0. And I'm going to be specific to my condition, which is the interval 2 to 6. There you go, if you guys can't see. Do you think I'm going to want the reasoning on the test as well? Yep. Aiden, get off the phone. Okay, one more, and then we'll finish after lunch. Okay, the last one says, is there a time when the particle is at rest? And I told you guys that word means something. That word means what? That the velocity is what? 0. So then let's go to analyze our table. If I go through 2 to 3, 3 to 6, 6 to 3, and 3 to -1, is there a guaranteed time? Right here. Now, we won't know exactly what number on the t value, but we know it does exist. I'm going to go ahead and bring it back up. So we know yes. What theorem do you think I'm going to use on this one? IVT. So I know -1 is less than 0, less than 3. And I want it as a function notation. V of 8 is less than 0, less than V of 6. And I'm going to write by intermediate value theorem. V of t is 0, since that is at rest, on the interval of, and we chose what interval? What to what? 6 to 8.